Hi everyone, thanks for joining this session at BuildDevCon. My name is Daniel Guzman Burgos. I'm a senior DBA at AlphaPoint. Today I want to talk about something that cost me real sleep this year. The observability gap between MySQL on RDS and on running yourself on EC2. This is part of the running OS as databases on AWS track. By the end of the next 30 minutes, I hope you'll think about your monitoring be it a little different. Okay, so let's dive in. So a quick word about myself, where I'm coming from, so you can calibrate how much to trust me on this topic. So right now I'm operating around 25 MySQL clusters in production. It's a mix of MySQL community and Persona XDB cluster, PXC. We have ProxySQL, we have Prometheus, we have Grafana. I have been a DBA for over 20 years now. I do have a personal blog, rendiment.io, where I just write about MySQL internals. So feel free to take a look. And I have some open source projects on my GitHub repo, which is github.com/nethalo. So yeah, welcome back again. This is how the whole thing started for me. It started with one day I say, okay, I need to right-side my MySQL fleet on AWS. Should be simple. I just need to look some metrics, see what's over provision, what is under provision, and just resize, right? So the first thing, look at the metrics. Which metrics, right? The first step, it can be some sort of deceptive, right? Like if you don't have experience or you don't know how to access those metrics, right? So before we go to actually RDS versus EC2, let's go very in depth on these metrics and what to look and how to look it and how to interpret that. So what metrics matters, right? So in this case, I'm going to use the use method. In case you're not familiar with the use method, it's utilization, saturation, errors. It's a framework from Brendan Gregg, Netflix engineer. I don't know if he's still Netflix, but he developed this when he was in there to have a very objective and clean method to deciding capacity, right? So the use method, it's proven, it's widely used, it works. Before going to the use metrics and what it's the metrics for the use framework and what are the metrics from each of those cases, I want to talk about something that it's very common misconception, or not misconception, but it's more like something that was just carry on while reading metrics on every team that have been working. That is probably not the best way to understand metrics, and is that average lies, right? And ironically, average are also like the most used aggregation metric to make decisions and important decisions, and sometimes that come up with surprises and why it's better to use P99s or P95 or something like that. So I have an example here at this part of the average CPU 30% graph. It's based on a real graph, and it's a CPU graph with 1 minute data points. And this graph, if you are not seeing the graph and someone says to you, the average CPU uses is 30%, you immediately will say, okay, we are over provision. We can size down things. We can save some money. Let's do it. Then you see the graph and you say, there are some peaks on there, right? How is this average 30%? Well, mathematically it is. It's real. But if you have decided and move on just with this piece of information without seeing the graphic and understanding what's going on, you will probably make a mistake. What's the important thing here? Using percentiles. So P95 and P99 show you what the DB actually experienced, like what it's really happening without smoothing the peaks, right? So the rule that I go by is right side also always on P95. What does it mean? That 95% of the time the CPU was under X value, right? The other 5% was above that value, right? That 5%, it's something that you can decide to take the risk. It's a calculated risk. So it's not that you're going to suffer most of the time. It's just going to be accurate. So always use P95 instead of average. Average are good for marketing. Percentiles are good for engineering decisions. Okay, now knowing that we're gonna use P95 or P99, let's go back to the use methodology. So the utilization, it's how busy are your resources. So for MySQL specific, there are 3 things to look at in terms of utilization. One is the CPU, of course, that's like the obvious one. The other is the INODB buffer pool hit radio, and the other one is the disk utilization and work. What's important on the CPU is the more obvious one. So if P99 is above 80% sustained, you're undersized. If it's bigger than 40% sustained, you're oversized. Getting P99s and P95s is easier, like Grafana, or if you're using regular CloudWatch, or if you're using something else, they all have aggregation metrics where you can calculate the P95 and P99, or you can use PromQL to calculate that also. So it's not something that you have to do the math, it's already there, and it's easier to see. So it's very, it goes very to accurate to say that it's mostly, the problem is mostly with oversized instances or the servers. People are thinking like, I prefer to have room for peaks or whatever, but if your P99 is never over 40%, you're oversized. You can reduce that. Don't worry about it. So that's the first signal. The INODB buffer pool ratio. This is not that obvious as CPU, but it's super important. It's pretty much saying in simple English how much data it's been read from the memory versus how much data has been read from the disk, right? There is a substantial difference between the latency of reading from physical memory from RAM um, versus reading from the disk. Even if you have now we have super fast disks, SSDs, or NVMs, stuff like that. There's still magnitude order of difference on reading that. So it's important to know this. You need to know that if you're reading way too much from the disk, you need more memory or better queries or better indexes. You need to do something, right? Your utilization is being uh, hit by that lack of resource availability. If you're on 99.9 or up, you can downsize. It's important to see that the the hit radio difference, it's by like a decimal, like 99% and 99.9. So it's a very thin line, but it's important to know how to measure this and how to interpret this, right? So, and finally, the IOPS, this and the throughput, also P99s, P95s. In AWS, you pay for provision IOPS, right? Usually, since there is GP3, you can also change the IOPS and the bandwidth of the disk. That helps a lot. It's cheaper than GP2, and it's also way cheaper than IO1. So, but you're still paying for that. You're constantly below that provision ceiling. You're paying for resources that you're not using, right? So that's something that you need to know to in order to make your calculation on cost. That it's usually, on my experience, people are not very to the detail on monitoring the disk, and when they do, they find a lot of money saving costs in there when they're properly changing the type or changing the provision IOPS or changing stuff. No impact on the performance and a good amount of save on cost. And in the opposite, if you're hitting the ceiling constantly, that's latency, aggregated latency for the queries. You probably need to increase either the throughput, the bandwidth, or the IOPS. So these are, in terms of utilization, the three most important metrics. Now, saturation is how much it's waiting in line. So the two metrics I always check is track connected versus MAC connections. What I see often is MAX connection is set on numbers incredible high that what it's doing is that you're allowing for a future problem on MySQL. Why is that? Because max connection is a safe variable. It's a safe for MySQL. It's saying like, I'm aware that I can put like 10,000 max connections, but the reality is that the database will start to suffer and will start to draw itself after, let's say, 100 connections, right? So people think that when they have low max connections and they start to hitting connection exhaustion, the solution is to increase max connection. That's not the solution. That you're making the problem worse, because the database is already suffering of contention, of high concurrency, and you just letting more work to come at the same time. So max connection is always over configured. It's always wrong. It's not useful for what it's intended for, which is protect the database. And that's something that you can easily spot when you see the threads connected. Threads connected, it's the actual number of connections that are being used. So it's important to check that, not just to proper set the max connection, but also to protect your database and say, okay, let's put it lower. I'll also save some memory, wasted idle connection buffers, which in bigger numbers, it tends to be something important. Sorry. The other one, this queue depth, it's how big is the queue, right? If this is constantly above 1, your storage is saturated. That means that this cannot keep up with what MySQL is asking for. This is the metric that catches what the CPU misses. CPU can be, okay, we're good on system, we're good on user, we're good on nice. We can even be good at IO wait, which means that when there is a disk operation, it's fast enough, but that doesn't mean that there's no queue, right? It could be that things are very fast, but the amount of things that the MySQL is asking at the same time for the disk is way too much that there's always a queue, and it's always above 1. You're in trouble when that is happening. So this is very important. This is a complement of what CPU is showing to you. This is what separates people who monitor databases from people who understand the database, what it's saying. Like low CPU with high Q means your disk is the bottleneck, not your compute. This is very important. You have to assign a bigger instance, and it's not gonna help. You need fast storage. You don't need more cores in this case. The final one on the use is errors. So what's failing? I track aborted connections, slow queries, and deadlocks. These are not capacity metrics. They don't tell you how much to resize. These are telling you where to investigate, okay? Aborted connection might mean the app has a timeout misconfiguration, or there is a network that is not very reliable, or the connection pool is misbehaving. But again, it's a signal, it's not a diagnosis. Okay, so this is more for you to tell you where to investigate. The slow queries that are growing and rate means that something changed, right? There's a change on index, there's a new traffic pattern because there is a new feature, there is a data growth that is significant because something was imported. Could be something on that. New query got deployed. Anything, but again, go investigate. It's not a capacity thing. It's not gonna tell you anything by itself. It's just telling you, hey, look this way. And deadlocks means concurrency stress. It's deadlocks are a design flaws in orders for transactions, in how you handle high concurrency on your app side. But it's delicate, right? So it's something that you need to go and check mostly on the app design. It's not that often on the queries. It's more like an order of the queries. So yeah, errors tell you when to investigate where. But for capacity itself, the important things are utilization and saturation. Good. So let's talk about the first case when you have EC2 instances with PMM. This is one stack, one pane of glass, and how it looks when you're monitoring everything from within the database. So, like this says, all the layers, one dashboard. We have a stack. Let's see here. This is an example of a Percona server for MySQL that is being monitoring with PMM. With PMM on each MySQL host, you install the PMM agent, which is basically a node exporter with MySQL exporter, and that the metrics goes to Victoria metrics instead of Prometheus. And then you have ClickHouse, where you store everything that is related with query analytics. So that's very high level of the stack. But the important thing is that you have everything on one screen. Okay. So this, for example, is the InnoDB details. It's showing you the means ratio for the buffer pool, how much data it's dirty, how much data it's available, the page creation, the read request, the write request. This one's the important one, the one that is at the bottom right. But everything's in there, right? Same for query analysis. You have out of the box query analytics in terms of query profile, distribution, impact on the database, details on execution time, how many times has been called, etc., etc. So, like I say, everything is kind of in the same pane of glass. And it's handy, it's very detailed, it's customizable, it's interesting, and it's good, right? But what is the real cost? This is a ballpark calculation of how it would cost if you're running PMM on a T3 medium with a 50 gigabyte size GP3 disk. This will work if you have one, probably three instances monitored. Because I mean, T3 instances has CPU bursts, credits, it had some limitations. But that's just the first cost, the money cost. There's an HA reality with PMM. PMM, for you to have PMM as an HA solution, high availability, officially it requires for you to have Kubernetes, right? So what does that mean? It's yet another infrastructure that you need to deploy, that you need to maintain. And if you don't have Kubernetes yet, you're not gonna deploy Kubernetes just for the monitoring solution. So this is the HA reality. This is something that it's important for you to know. So be very aware of that. This is a shameless plug. I wrote a non-official HA solution that it doesn't require Kubernetes. It's on my GitHub. It's here. It's PMM HA. It just uses HA proxy. take a look, but it's not official. The official way is Kubernetes, so that's another thing to keep in mind on codes, because you don't want your monitoring tool to don't have HA, right? You need that to be resilient. What are other costs that the pricing page won't tell you? You're the guy that it's on call for everything, right? If it goes down, if something happens, it's on you. You have to go figure it out what's going on, fix it, restart it, make sure you didn't lose metrics, and if you lose metrics, well, restore very fast. All the patching and upgrades are also up to you. Not only for PMM itself, but for the Linux box where it's running, security patches, upgrades, etc. Scaling the PMM server, it's like I say, if you have more instances, you need a bigger PMM server. So you also need to do a capacity planning for the monitoring tool. Okay, so let's talk about RDS. RDS, the monitoring, on the contrary of PMM, which everything is in one tool, you can have a single pane of glass, and that's it. You have 3 layers because you have 3 tools, and it's 3 different AWS services, so it's 3 builds. So it gets messy. Okay, so you don't get a dashboard, you get a stack. You have CloudWatch metrics for server level metrics, CPUs, connections, IOPS, memory. You have the enhanced monitoring. That's the next tool, next part of the stack. It has more detailed monitoring for server logs. It goes to CloudWatch logs. It's not metrics. And then you have the performance insights, which is more related to the database, DB load, wait events, stop queries, all that stuff. There are very important things on the 3 of them. CloudWatch metrics, you have 60-second resolution. That's it. And your retention decays after 15 days. What's the difference with PMM? With PMM, you have by default 30 days, but you can extend it. You can put this as many as you want, and you can hold 3 months, a year, whatever you want to do it. Just put a disk and it will be there. And the performance inside, it's free for 7 days. And performance inside is gonna deprecate on June 30 this year. They're gonna deprecate this, and they're gonna, by they I mean AWS. AWS is going to deprecate this, and it's going to replace it with something else, which is better, but it's costly. It costs more. And AWS is literally telling you this right now. If you go to your console and you go to Performance Insight, it says Performance Insight is moving to Amazon CloudWatch on June 30, yada yada. It's going to be replaced with something called Database Insights in CloudWatch. It's not just a migration, it's a change in the price model. It's roughly 6 times costly. So for the same retention window under the new Database Insight Advanced, the pricing will be around $9 per CPU per month. Okay, so this is important. You're seeing this on April, on June, this is gonna be a reality. What's the operational tax here? Like, you have 3 different places to go on RDS, right? You have an incident, 3 a.m., 2 p.m., doesn't matter. An incident is an incident. You have to go to CloudWatch console to check CPU connections. CPU usage, connections, electricity, the enhanced monitoring to see details, not only on the process. You want to see if your disk usage is hitting limits or not. That's also enhanced monitoring. DVI or currently PI, which query is allowed? CloudWatch logs inside, see the log query log, and then repeat for the end cluster affected. For tools and clusters, the cocktail switch is horrible. A parenthesis, there's the RDS exporter on PMM, which will read from CloudWatch and will load things to PMM. So if you already have PML or you have a mix of RDS and EC2, whatever, you can put it there. But that has an additional cost of that might hit when you hit the API limits on requests. So important to know. And how does it look when you have EC2 and PMM? You just go to one tool, PMM, pick a cluster, same screen, everything, OS engine queries. You need to go to see something specific for a query, go to Quan. It's easier. So far, what are the trade-offs? It's cost. Both have cost. Some of them have more hidden costs, like PMM. The other are more dollar costs, but it's managed by AWS. This one, PMM, you have to manage yourself, but you have the single pane of glass. So far you can see that what are the trade-offs, and you start to look what like picture poison, right? You know. So let's try a scenario. So 3 MySQL instances, R6H, so Graviton, X large, 4 CPU, 32 gigabytes, US East 1 on demand, no reservoir instances whatsoever. So same flip, same goal, very different builds. This is per month monitoring and observability only, not the database itself, just what it costs to watch it, okay? If you stick with the minimal RDS setup, which is basic CloudWatch plus the performance inside on the free tier of the 7 days, you'd cost it $0 a month. Good, no problem. But you only get 7 days of history, no OS level metrics in a graphable form, it's just logs, and a way to right side under long trends, okay? If you go EC2 plus PMM, we already mentioned this, about $34 a month, where you have all the metrics, percentile support, query analytics, configurable retention, but 2/3 of that cost goes to the PMM server, right? So this is where it gets interesting. With the change after June 2026, this change hard. DVI Advanced will be pretty much around 3.5x PMM cost for this scale, right? And the gap grows with the flip side, more RDS monitoring, bigger amount of money, and the gap will increase. What's the twist? The twist is that this is happening, right? You have, this is April, May, you have month and a half, probably 2 months. I'm not very sure if it started on June 1st or middle of the month, but we're talking about weeks here. So it's important to know. This shows more clearly what happened when the fleet grows. the EC2 PMM graph line. It's almost a line. It's very linear, let's call it. The slope is very low. It's not that exponential. With DBA, it scales linearly, but per CPU. So it's a bigger difference. It's important for you to understand this. Overall, the outcome is the same, and your goal is the same, which is metrics as detailed as possible, as long as possible in terms of data retention, right? So that's the different cost. But don't forget about the hidden costs of EC2 and PMM. If you're okay with paying those costs of maintaining security patches, upgrades, all that stuff, remember the HA, the official HA requires Kubernetes. That's you have to play with that. It's that balance. Right? It's important to remember what the pros and cons of both options. So which one should you pick? There's no universal winner. The honest answer is depends on the situation, depends of what you want to, what you're willing to accept as something that you might not have, or it depends on every different team and reality. This is pretty much like a summary or just a list of things that might help you figure it out on which bucket you are more aligned. So pick RDS and DBI when it's a small team, no dedicated DBA, same fleet, very low number of instances. You value that someone else manage your patching, your backup, your HA. Cross-account monitoring native, that's important. You have cross-account. You are already integrated with CloudWatch. Your whole notification system is integrated with CloudWatch, with Amazon SNS, with Lambdas. If you're already there, integrated, like adding this is just super easy. And the short window troubleshooting is enough for you. Like you don't need, or you think you don't need more than 30 days or 3 months or whatever. This is good for you. What about EC2 and PMM? So choose this one when you have large fleet, large amount of instances. DBA there is just gonna be a lot of money. You have DBA expertise in-house. That not necessarily mean full DBA. It could be IT people that are database savvy or a dev that can figure out things. You need long horizon trend analysis. Like you want to know what happened on Black Friday last year, right? That's bigger than the 7 days. So that is important. You need log access, you need custom tuning, you want Percona features. You don't want to be vendor locked, right? You want to maintain your options open. So portability matters, right? You're probably not moving away from AWS, but you want to be multi-cloud, so you're gonna use Google Cloud and you're gonna use Cloud SQL or Azure. Then it's PMM is the right choice for you. You're not gonna be vendor lock in there. It's multi-cloud. It works on hybrid. It also works on on-prem. So that's also something important. And if you already operate with Kubernetes, then it's just another deployment on your Kubernetes cluster. So you already have HA and you know how to deal with that. That's very important. If you already have that, just go with PMM. So it's important to know that the observability gap, it's just one of many gaps between RDS and EC2. Version control, bin log access, replication topology flexibility, that's important, extension support, tuning depth, all those matters, right? And all that are part of the same decision. RDS versus EC2, it's a bigger choice than just monitoring, of course, but monitoring is the gap that nobody properly calls out. That's why I wanted to put the numbers today. So here's my ask: do the full math before you choose. You already chosen, know what you're actually paying for, because the price tag moves, and it's moving right now. It's going to change a lot on June. So be aware of that. That's it. Thank you very much for your time. Thanks for coming to the talk. Thanks for Build the Con team for having me. If there's some questions, you can hit me at my repo. I have only my blog on rendiment.io. Yeah, I'm around. Thank you very much.